As we look up into the night sky, we are reminded of how small we are in the grand tapestry of the universe. Yet, even in the vast expanse of the cosmos, there is one star that commands attention, a star whose massive size, fiery glow, and imminent fate captivate the imagination of astronomers and dreamers alike. That star is Betelgeuse. It is part of the Orion constellation, but it's so much more than just a point of light. Betelgeuse is a living, breathing giant, a star that is nearing the end of its life. And what a life it has been! Larger than our sun by more than 1,000 times, glowing a deep red hue. Betelgeuse is one of the most extraordinary objects we can observe in the sky. Yet, despite its brilliance, Betelgeuse is also a dying star. It's already entered the final stages of its life, and soon, it will meet a spectacular, violent end, supernova. But imagine for a moment, what if we could travel to Betelgeuse? What would it take to journey from our home on Earth, to cross the expanse of space, and to reach one of the most spectacular, yet ultimately fleeting, stars in the universe? What challenges would we face? What discoveries would await us? Join me as we venture into the realm of science fiction, into a world where interstellar travel becomes not just a dream, but a very real possibility. We'll explore the immense distances, the cutting-edge technologies, and the wonders we might encounter as we embark on a journey to one of the most distant and magnificent stars known to humanity. Betelgeuse is not just any star. It is an astronomical titan, a red supergiant that sits at the end of its life cycle. It has exhausted much of its fuel, burning through its hydrogen supply in a fiery frenzy, much faster than our sun ever could. As it does, it has expanded to an unimaginable size. To put it in perspective, if you replaced our sun with Betelgeuse, the resulting supergiant would stretch far beyond the orbit of Jupiter, engulfing the planets Mercury, Venus, Earth, and Mars in its fiery grasp. This star is as massive as it is ancient, and its red glow tells the story of a dying star in the final throes of its existence. But beyond its impressive size, Betelgeuse's life story is also a ticking clock. For centuries, scientists have been eagerly watching the changes in Betelgeuse's brightness, trying to predict when it will undergo the final act of its life, a supernova. This catastrophic explosion will release more energy in a single instant than our sun will release in its entire lifetime. It will light up the sky with the brilliance of 1,000,000 stars, and we will witness the birth of new elements, dust, and gas that will someday give rise to new stars, planets, and potentially new life. This is a star in its twilight, a beacon of cosmic evolution. Yet, for all its power, Betelgeuse is an inaccessible mystery. It beckons to us, but it lies too far away, 640 light years to be exact. And in the vast emptiness of space, this is a distance that is almost impossible to fathom. 640 light years. That is the staggering distance that separates us from Betelgeuse. To make this tangible, let's consider how far light travels in a single year. Light, the fastest thing in the universe, travels at a speed of 186,000 miles per second. In 1 year, it covers about 5.88 trillion miles. Now, imagine traveling at that speed for 640 years. That's how long it would take to reach Betelgeuse if we were able to travel at the speed of light. But with today's technology, we're far from being able to achieve that. The fastest spacecraft we have, NASA's Parker Solar Probe, travels at roughly 430,000 miles per hour. If we used this spacecraft to make the trip, it would take us a mind-boggling 17,000 years to reach Betelgeuse. These numbers are so vast that they seem to defy reality. How could we possibly travel such distances? Is there any way to shorten this journey so that it might one day be within the realm of possibility? The answer is yes, potentially, but it would require extraordinary advances in propulsion technology, breakthroughs that will push the boundaries of human ingenuity and force us to rethink everything we know about space travel. In order to make the journey to Betelgeuse a reality, we would need to create spacecraft with propulsion systems far beyond what we have today. The question then becomes, what kind of technology would we need? One possibility is the use of ion drives. These engines are already in use today, powering long-duration space missions like NASA's Dawn spacecraft. Ion engines work by accelerating charged particles to extremely high speeds and using this ionized matter to propel the spacecraft forward. The main advantage of ion propulsion is its efficiency. It consumes far less fuel than conventional rocket engines. However, ion drives are incredibly slow. Even with ion propulsion, a trip to Betelgeuse would still take us centuries, far too long for a human lifetime. To shorten the journey, we would need to harness the power of nuclear fusion, the same process that powers stars like Betelgeuse. A spacecraft propelled by nuclear fusion could theoretically reach a significant fraction of the speed of light. This would allow us to make the journey in a mere few decades instead of millennia. However, the technology to build such a fusion-powered spacecraft is still a long way off, and we would need to make major breakthroughs in harnessing fusion energy safely and efficiently. The final frontier of possibility lies in the realm of theoretical physics, the concept of warp drives. Imagine a spacecraft capable of bending space-time itself, allowing us to effectively travel faster than light. This idea, first proposed by physicist Miguel Alcubierre, involves creating a bubble in space-time where the spacecraft remains stationary within the bubble while the space around it moves. Although this idea is far from reality, it presents an exciting possibility for the future. A warp drive could make interstellar travel a matter of days or weeks, not centuries. While these methods are far from proven, they give us hope. Hope that we could one day push beyond the boundaries of our current understanding of space and time and turn the impossible into the possible. Imagine embarking on this journey. Imagine leaving Earth, and as our planet shrinks into the distance, we enter the vast, dark emptiness of space. The stars around us grow sharper and closer, like brilliant diamonds in the sky. As we travel further, we'll see the stars change. We'll pass through the Kuiper Belt, the Oort cloud, and the regions of space beyond the edge of our solar system, each moment revealing something new and alien. But with time, the stars will begin to blur together, and the void between them will begin to feel more palpable. There will be no noise, no sound, just the silent hum of our spacecraft, carrying us farther and farther from home. The isolation of space will set in, and it will become clear just how vast and lonely the cosmos truly are. Yet in this isolation, there will also be moments of pure wonder. The beauty of distant galaxies, nebulae, and the occasional supernova illuminating the sky. As we approach Betelgeuse, the experience will change again. Betelgeuse, with its immense size and fiery glow, will fill the view screen of our ship. We'll see it pulse and shift, its outer layers expanding and contracting. It will be a spectacle, the raw energy of a dying star, the end of a stellar life cycle. There will be a deep sense of awe at witnessing something so extraordinary, something that so few have ever seen up close. Eventually, Betelgeuse will fulfill its fate. As we witness this star reach its ultimate end, We'll be spectators to one of the most magnificent events in the universe, the supernova. This explosion will be felt throughout the galaxy, sending out shockwaves that can trigger the formation of new stars and scatter elements that could form the building blocks of life itself. As Betelgeuse explodes, we will feel a profound sense of connection to the cosmos, to our place in the universe, and to the cycles of life and death that shape everything around us. It will be a fitting end to our journey, a reminder that even the greatest stars must eventually fade, making way for new beginnings. In that moment, we will know that our voyage was not just about the destination, but about the journey itself, the quest for understanding, for discovery, and for the unrelenting curiosity that drives us to explore the unknown.